Um, so hello everybody. So today I'm going to talk about why and who we want microservices in our application. So first of all, who am I? I'm a mobile and backend developer. I'm a Techno employee and I work since 4 years at Le Roy Merlin. So just to give you the context, I work on the same team as Camille. I don't know if you remember our talk yesterday. So in our team, we are making a mobile application for our employees. Those applications are very wide. It's a simple product sheet with the price and stock, or it can be a after-sales application with electronic signature and very wide application. And at the beginning of the project, we had one big application with all the features in it. And by the time going on, we were making some other applications that were still very big. And that was causing us issues, several issues. So just to give you a context of our architecture, that was at this time. So our architecture, sorry, I speak Franglish. So our architecture was quite simple. We had a backend here in the middle that was consuming a lot of API from the information system. Those API were very of a different kind. It was SOAP, REST, or even a Java RME. And this backend was an abstraction of the information system for our front application. And this application is an Android application that was consuming our backend through a REST API. So, as I was saying, our application was growing more and more because we were adding a lot of features. The packaging size was increasing. We had many versions. We had numerous and complex deployment because our application was not only deployed in France, but in all other the country where Le Roy Merlin is working. And it was hard for a junior to dive in because the technology was a large range of technology. Because in our team, we are full stack developer. We develop on the mobile and also on the backend. So our strategy at this time was simple. So we decided to go microservices because it was what everybody else was doing. So we decided to have one backend per functionality. At this time, we decided also to review our stack to make it easy for other developers to dive in the backend and to develop on it. And we decided also to review the way we were deploying application to use Docker, Rancher, and Consul, and also I forgot Traffic. Before that, we were deploying our backend using RPM, where the jar was put inside and deployed using Run like Puppet. Okay, so once we have split our backend into a little microservices, our architecture was looking something like that. It's more complex, but it was more easy in the code because the backend were usually now consuming only one API and were consuming a lot of API. So, as I was saying, microservices was a way to make to separate the responsibility of each backend, but we found that it was also necessary to review our stack and to find a new stack that was more easy for developers to develop with, and so we could provide faster some of the application. So because we are full stack developer and most of the developers are coming from Android, we decide to use those tools on our stack. We decide to use Spring Webflow. because on Android we are using a lot RX Java, and we like reactive programming, and so Spring Web Fluid was giving us that. And because it's also non-blocking, and it was very adapt for our point of view to microservices. Before that, we were using Maven, and for the same reason, Gradle is already used by Android, and we found Gradle cool, so we decided to throw away Maven and to go on Gradle. Because also we were using a lot of Kotlin in our Android application, we decided to go on Kotlin 2 on the backend side. And to make that possible, we developed two things. We developed a Gradle plugin to help us to apply what we did on our project, like a parent Maven. And we developed also a library. So what this library is doing, it's allow us to enable Spring Web Fluid on our project. It gives us the way to get the configuration for the backend, because we have an externalized configuration. It gives us also an error normalization, because we wanted our backend to always give the front the same model error when there is an error, and also it gives us also normalization of the data format, like for the date and stuff like that. Because our backend are simply REST API, it should have a else, because we want to monitor those backend. So it helps us also to init the else, and there is a system of auto registration of the probes. The probes are the bin and the services we found critical for our application. It helps us to secure the backend with OAuth, and it provides multiple API clients for the API in our information system. So just to give you a little view of what a backend is in our company. Our backend are very, very simple. Basically, there is 3 layers. We have a controller layer that is only defining the route that will be available on our backend. And after, there is a service layer that will handle the business and will choose which API it will call to get its data. As I was saying, our applications are deployed in multiple countries, and in Leroy Merlin, each country has its own information system. So what we are just basically doing is providing a different implementation of the service regarding the country. And we have a third layer that could be used by the same implementation or not, which is just a layer where we are making the call to API or data access object to a database and stuff like that. So now, just to give you some line of code to show you who our backend are simple. Just so that is the way we are applying the Gradle plugin to our project. Just I don't know if you are familiar with Gradle or not, but so we found that this view more simple than with Maven. And I will just show you those 3 layers in Kotlin. So, for example, here we have the controller layer where we are defining the route. Here, just a simple gate on the bus path of the backend. And the controller is made of 2 classes. This Kotlin DSL, and an handler, which will just describe who the server request will be handled, by which bin it will be handled, and who it will provide a server response. We have We have the second layer, which is the service layer, which is here in this example, just using another bin, which is my API service, which is the bin that will make the request to our API. And it's just consuming the API, getting the model, and map it to another model. Just backend are most of the time doing that. They are very simple like that. And that is the last layer. That is the way we are doing a request. So it's very easy. If you are a developer, I think you have understand what I have wrote. For those who are coming from the Spring world, there is also Feign, for example, which is like retrofit. Just a word about that. We didn't use Feign because it was not using the web client provided by Spring Webflow. So now I think if you are familiar with continuous delivery, this is pretty simple. So what we are doing for deployment now is very simple. We are building on Jenkins. We are using Sonar as a Sonar gate for quality. And once we have built our Docker image, we are pushing it into the registry and declaring a new services on Rancher. And then we have traffic that is looking at the container and which is our reverse proxy and declaring the new route. We are using traffic because mostly of the time in development we have many features, and so regarding the feature, the name of the feature branch, we are then providing like a dynamic DNS to the good container. So the result of going microservices give us a lot of advantage that you often retrieve in other projects. But for us, it was to have a smaller code base, which means more maintainability. It was for us also easy to deploy. We have also more system resilience because we had a lot of issues before. Our application was crashing because only one feature was crashing. But the disadvantage we found, the two big one, were we have more service to monitor, obviously, but also it was more difficult for us to find the root cause of the issue because now the logs are everywhere and the issue can be everywhere. So that's all naturally. Because why just reorganize the backend? Because usually when we are talking about microservices, we often think about backend, and that was the start of our kind of project. Now we decided also to let's divide the Android application too. So that's as the main brick of our an Android application in our team. We have some feature in it, all packaged in the same application. And we have also some bricks that are reused in the other application, and that could be better way. We have, for example, a feedback service that which with the user can send feedback to us. We have some an help brick, an authentication brick, and anyway, some brick. And so we decide to divide it like that, where we retrieve two applications, an app with the feature 1, an app with the feature 2, and so on. And we made some application with the authentication preferences, scanner, analytic, and stuff like that. And how we are communicating between our application and between those services. So for the services, we are using Android services, and between the application, we are using widget. So as I was saying, for the services, we use Android services and specifically band services, and we use messengers as an interface. We try to use AEDL, but it was hard for us to maintain because when we wanted to change the model or when we wanted to add a new method, we were breaking these services and we had to deploy and release a new version of it. and also the already deployed application were breaking. So just to give you a little view of how it's working in your team. So now when an application wants to interface with our services, we provide it a manager, like in this example, a product manager, when we have a lot of function. And so this manager, what it's doing, it's just binding to the services. And what it's doing is when we make the request, it sends a map, like an hash map, with the version code in it, request code, and the request data when we have complex data. And those data serialize using JSON. Then the service, the Android services, gets this map, and so because it has the version code, the request code, we basically have a big switch, and using this request code, we are making the good request to the API that our services is using or anything else. And once it have retrieved the data, then they are serialized again as JSON and sent back to the application. And by using this mechanism is we ensure that we can change the model, for example, adding a new field. But also if tomorrow we are making some breaking change, we can use the version code to use to allow us to keep the application and just to deploy the service again and to make it work with the application using the new version of the service, but also the already deployed application that needs the older version. So a need we have also with our application is that sometimes an application has to be aware that another application is installed. For example, in the product application that is providing information, sometimes we want to print again the label of this product or to change the stock. But we wanted to not have to implement that directly in the code of the product application. So we have to find a way for the product application to discover that it could do some stuff with the product. So we decide to use widget. So basically our application just ask what are all the widgets available with the product. And why we use widget, we could have used broadcast receiver, for example, or stuff like that. We use widget because by using widget, we are allowed to implement some business rule in the widget. And so, for example, if we want a product to not have access to an application because it's a special product, we can do it. So, is it over? Not again, we still have a little problem. By dividing our Android application to several applications, we are facing at the beginning a major issue. We had at the beginning one flavor per environment, one for dev, Calif, pre-prod, prod, and one flavor by country. We had 11 countries. And because you have two build type, it was just a big mess. So at the first time, the first thing we did is say, okay, that's not possible. Let's have in the application big property files, like property files where we will store all the different URL to our backend or specific for a country. But also we found that it was hard to maintain, and it could be tricky when we were deploying to production. It could lead to some unexpected behavior. So what we decide to do is we have a break called Passport, which is providing our authentication. Now it will also provide the configuration to the application. So basically what we are just doing is that we have our application that is asking Passport its configuration. So to do that, we use the application ID, which is defined in the Android manifest, and then Passport is asking the backend its configuration, and using this application ID retrieve the good configuration. And because Passport know in which country it is and in which environment it is, it retrieve properly the good configuration and give it back to the application. So now from 44 flavor, we only went to 12 flavor, which means at the end only 24 APK available, because you also have 2 build type. And all our applications are now only 2 APK, one for debug and one for release. Okay, so just to end this talk, we found that the microservices approach can work on Android too, and that's maybe where it was the most successful and where it was more interesting to do. It gives us also some new opportunities, like for example, inner sourcing. Inner sourcing is like open source, but inside your company, because now with this service approach and widget, it's allow the other country to develop application and to integrate them with our already existing application. And also, if you are more interested, we have a GitHub mobile tribe where you can find our Android framework. That's all, but go there quickly, because we might go to GitLab soon. We don't know yet. So that's all for me. So if you have any question.
You know what I'm going to ask. No one? Okay, cool.
Okay.
Thank you, Adrien.